In this topic, we are naming binary ionic compounds. So here we are given a table and we're asked to fill in the name and the empirical formula of each ionic compound that could be formed from the ions in this table. The first, in row 1, our cation is sodium metal ion and our anion is chloride. Remember, these are ionic compounds, and we should see that we have a metal and a nonmetal, or a cation and an anion. And that is what we see here. All of these are cations, and all of these are anions. Simple binary ionic compound. So what would the empirical formula of this be? Well, an easy way to determine the empirical formula of an ionic compound is to begin with your ions. So our cation is sodium, and let's write its charge. Our anion is chloride, let's write its charge, +1 and -1. If I want to get the empirical formula from this, we can use the crisscross method. The charge, the value of the charge, this 1, becomes the subscript for the cation, and the value of the charge of the cation becomes the subscript for the anion. What this gives me is Na1, Cl1, and we can omit the 1 and just have NaCl. Now the question is, why does this crisscross method give us this empirical formula, and how do we know that this is the correct empirical formula? Why does this method give us that, and how can we assume that it's correct? Well, the answer is we have to think about, by definition, what a compound is. By definition, a compound is similar to what we have said about the definition of an atom. An atom is neutral. A compound is also neutral. So in order to be neutral, this ionic compound made up of cations and anions must have the charges of the cations canceled by the charges of the anions. So this empirical formula tells me that sodium metal ions and the negative chloride anions are present in a 1-to-1 ratio relative to each other. And that makes sense. Look at the charge of sodium metal ion, +1. Look at the charge of each chloride anion, -1. So for every one of these, I have one of these, and the charges are canceled. So when you look at your empirical formulas after you've derived them, you should step back and say, well, what's the charge of one sodium metal ion, or this cation? What's the charge of this anion, or polyatomic ion if it is one? Do the charges cancel out, and do I have a neutral compound? Now remember, empirical formulas are simplified chemical formulas. So we need to double check and make sure that these subscripts are simplified, and they are. It's 1 and 1. I cannot simplify that anymore. So our empirical formula would be NaCl. Following the naming rules, if I were to name this compound, you write the name of the metal, sodium, and then you write the name of the nonmetal with the IDE ending. Chlorine would become chloride. Here's a little reminder on how to name simple binary compounds that are ionic and have invariant metals. Our invariant metals are our main group metals. Metals in group 1A, metals in group 2A, and aluminum. Here, sodium, we can see that it is a main group element. It's in group 1A. So just to review, what we did was we identified that we have an ionic compound and we have an invariant metal, sodium. It's in group 1A. So just to indicate there are invariant metals in group 1A, 2A, and aluminum 3+. We named the metal as written on the periodic table, which is what we did, sodium. We named the nonmetal with the IDE suffix, chloride, sodium chloride. Let's look at the next one. we have sodium metal ion, and we have fluoride. If I want to get the empirical formula, first thing I do is list the ions and their charges, and then I just crisscross. And this is +1, and I take the value of that charge and place it here. I end up with Na1F1, which is simply NaF. So the empirical formula is NaF, and the name of the compound, following our rules here, name the metal as written. That would be sodium. Name the nonmetal with the IDE suffix, fluoride. We can see that the charges for sodium are going to remain the same, and the charges of our anions are all -1. So we can go ahead and jump ahead and fill out the rest of the table following the same pattern, NaI and NaBr. This would be sodium iodide, and this would be sodium bromine bromide.